Hello, and welcome to another video from Ellensburg, Amplifier Repair and Service. Oh, today we have ourselves a Hifonics board. This is the, what is this? This is the BEX2550.1D. Pretty fancy number there for an amplifier. It's been quite a while since I've done one of these on video. This is just another classic, typical design of an amplifier. And over time, once you see one of these, you kind of already know what you got to do. So this came in with a severely failed power supply. As you can see here, I don't know the history of this, don't know what happened to this, but it definitely had a failed power supply. I'm just going to double check and make sure that, oh, I pulled the drivers and took out the drivers. Just checking the gate resistors. 22 ohm gate resistors. So we're going to be using the 064 ends like they had originally. You can use something like the IRF P7530 is my kind of go-to power supply transistor. They run great with the type of drives that most all these amplifiers use. So this uses the standard 649s and the 669 drivers here, which I'm not sure that I have. 649, 669 drivers. I'll have to look and see. I usually use the 600 and 631s. I'll get back to you on that. But we are going to use the 064s in the power supply. And then the outputs were the IRF-P250 ends, which had a shorted transistor, oddly enough, on each bank. I got to do some cleanup on this board. It is just not in a condition for me to work on. So I'll just get a little bit of isopropyl alcohol here and just clean up my area. And of course, it's got to look good for video. I mean, right? It's got to look good. So I already checked. I made sure that the power supply drive card was okay. I do believe it's still at 26 kilohertz. If I remember right, it's been a few days since I started this amplifier. Typical loose rail capacitors. Had these guys come in with these snapped right off. And I left the old transistors in place here. So we got a 1, 2, 3, 4, 1, 2, 3, 4. I have a bank of 4, so 4 and 4. Remember guys, anything in parallel should be matched. So we're just going to get the IRF-P250 ends out. Now mine have the short legs, which still works. You just got to be kind of careful and not get too fast on what you're doing. Oh, never mind. I thought they were using the long legs. They're not. They're short legs. All right. IRF-P250 ends. IRF-P250 ends. We'll get those ready. Get some drivers. What do we need? The 669 and the 649. Well, hold on, guys. Let's see what I got here. Oh. Well, guys. I don't know what I was thinking. I was thinking I didn't carry the 649 and the 669. Well, I do. I need 1, 2, 3. Right? Is that what I need? 649s. I need 1, 2, 3, 4. I need 4, yeah. So it's 4 and 4. It's early. As you can see, I still have my coffee here. So there's 4 649s, and here's 4 669s. I must have ordered these. I did not have these in stock about mid-2022. Yeah, we'll blame it on the old age. Alright, so let's get this drive put back together. I have a little map on the wall here. I wrote down on a post-it note, as I always do, guys, when you take drivers out of a board and you don't have the board memorized, I don't recommend memorizing every design out there unless you're really into memorizing things. I always write down what comes out of where, and you can kind of see right here is where I'm working. And I have a little map on the wall that I drew out for the drivers. How many times have you pulled drivers and then you had to go back on the board and check where's your positive 12 volts, where's your ground, where's your input, where's your output? I mean, you can really spend some time digging into your drive, depending on the drive, if you don't keep good record of what comes out. Now, I'm going to get my little map here. And on my little map, I put a big old line that says card, so that tells me the direction of my little map. So, the 669s will go in, and I'll just kind of work my way across the board here. 669, 669. And then the 669 over here. And then the 669 right, let's see here, over here. And then don't forget you also have, the proper direction. So you have your base collector emitter pin out that you gotta keep track of. Make sure you don't put your transistors in backwards. Then you'll have an unhappy drive. It will make a lot of things unhappy if you hook them up backwards. 649, 649. Oh, hold on. I have a 1381 in the mix here. I need 2 more 649s. Are the 1381s compatible? Probably. I need 2 more 649s. Where did this come from? That's strange. I don't know where they came from. Yeah, 669. Okay, 669. Okay, what's this? 1381. Oh, somehow they ended up. Sorry guys, don't know how that happened. I just got done counting inventory for the first quarter of 2023, and the one thing I don't count is the small driver transistors like this. I just track how many I purchase, and then I look and see what I have left, and then every quarter I just order more. I probably should count these, but I don't. Otherwise, it'd help keep those little trays in order. Where was I? 669. Oh. Oh. I needed 2 more 649s. Oh, I'm really messing up today, aren't I? 649. 2 more 649s. Oh, not 669. 2 more 649s. Oh, that's how those two transistors ended up over there, because the tray is right below it. Oh, it is early. Alright, 2 more 649s. Alright, guys. No more messing around. Okay. 649. I love it when they cram these things in right in between the transformers. And what are some of the hottest things? What are some of the things in an amplifier that gets the hottest? Yeah. So the reasoning behind putting your drivers in between two big, fat transformers, yeah, not sure the mentality of where that came from, but I probably wouldn't have done that. I probably would have taken these drivers, I'd have brought them out somewhere that doesn't heat up, or at least shouldn't heat up. But yeah, I'm not an engineer. I just fix what burns up. I just fix whatever comes in the door. Well, most times. Some things I don't fix. So if I tell you it's not economical to repair, it's because it's probably going to cost you more than what a new one's going to be worth, or more than what a new one cost, or a percentage of the new one. If I see that your repair is going to be 60% up over 60%, then I will let you know it's probably not economical to repair. Have you ever tried to squeeze transistor legs into holes that are so tight in between transformers that you gotta shake your head? I should have been an engineer. No, because then everyone would hate me. That's probably a bad word to use. Dislike. Everyone would dislike me. Yeah, I know, right? Using a Haco 301 here, FR 301, to nail down these drivers. You can find the list of equipment down below in the description for my Amazon affiliates stuff. I've had a couple requests in the past to offer a list, so I did. So it's out. It's available. It is down below. I'm probably not going to use the 301 for the rest of that. I will use my 888. Iron to finish this task. In the meantime, let's dig up some 064s. Do I have any available? Oh, I got some in a tray. Then I got some more coming. Of course, on my order. The 064s I use as a replacement in the cab amplifiers. Tip for you guys. So how many? 1, 2, 3, 4. I need 8. Oh, hey, let's throw things around. 1, 2. Uh-oh. Different codes. 1, 2, 3, 4. Hold on, how'd they do this? Did they do 2 and 2? Please tell me they did, because that'll really help. Did they do 2 and 2? They might have. Well, there's 2 transformers, so I bet they did. What am I doing now? I'm determining my sets of gate. How many? They did 2 and 2. Nice, nice. So, with this amp, you need at minimum pairs of 2s. There's 1 transformer right off camera there. There it is. 2. So there's 1/2, and then I need 4 more. Do I have 4 more that are matched? 26, 26. I do have more down below. This is just my trays that are in front of me. What do I have? 26, 26. Oct 6. I had used these. You can see I had used these. Sorry, my Hacko, my 301 tried to desolder my thumb. You can see I used these in the past to do some epoxy work. Don't worry, they're just fine. I just used them for some epoxy work on a board a couple years ago. Yeah, early. Yeah? No, sorry. But yeah, you can see I used these before. Oh, hey, I even wrote on the back the code to keep them paired. All right. What am I doing? The drivers. I will use some Kester 44 here for the drivers. What I like about using the FR301 is it's got a little bit more heat, a little bit more mass to help solder things down on the drivers here. Can be somewhat of a pain to solder if you are not running enough heat. But that FR301 can be a little bit of a pain to get in between these drivers. It's doable, but I figured, we'll get it done with the 888 here. I use the Kester 44 solder on the drivers, diodes, Zehners, resistors, and then I'll use my other solder for like primary traces. For everyone that just loves the lead-free world, I'm kidding, nobody loves lead-free solder. This other solder that I use it's not lead-free, but it does have a lot of tin in it, which has a little higher melting point that I use on the primary traces. Can handle the heat a little bit better until it gets too hot, and then that kind of solder just breaks down. There it is. There's all your drivers soldered in place. We're just gonna cut the legs off. You can see maybe you can't see, you can kind of see the spots where I got a little heavy on the solder, just from the angle that I had to get to the pin. So what we're going to do is we're just going to use the 301 here to kind of clean up these solder joints. Maybe, once it heats up for me. Give me 1, 2, 3, 4. Nice. All right. Just had to clean up these solder joints. See, it's a little easier to get in there with the 301 after the legs have been cut off. And I just make sure they're soldered well. Drivers take a ton of, not a ton, just a massive beating, depending on how someone has these amps hooked up. You could have the world's worst enclosure just beat one of these things to death, and something's going to give. So now we want to make sure that we don't have any loose solder on the board. That'll fall off and short out any components. So sometimes when you're soldering, you got to be careful when things drip onto the primary traces here. It won't really stick to it. It'll stick a little bit, but if the flux heats up, it'll fall off and land on the board and start floating around and short something out. Then you'll get it back. So there's the drivers. Make sure there's nothing conductive under my mat. Now, with my meter, I should show my gate. Nope, I sure won't, because these guys. Hold on, what do we got? Let's make sure my gate resistors are still present. Yeah. Let me make sure that my ground traces are present. Yeah, all right. And the capacitors are charging. Good. 61. Why am I not showing a pull down? Oh. I love these boards. Before I step on my own toes, there's something interesting about this board, which I'm going to tell you what's on the meter, and you tell me what we're missing. 3.8 megs. 3.8 mega ohms. All right, let's go to the other side. 3.8 mega ohms. Remember, these are in groups of 2. 3.8 mega ohms. Well, what are we missing? And we're not missing because it's not, or it's not missing because it's burnt or anything. It's not missing because I've overlooked it. It's missing because it doesn't exist. There's no pull down resistors. Yeah. There's nothing to pull the gate circuit back to ground. Well, what kind of disaster can that spell? Oh my. Yeah. Right on, guys, right on. And they got their snubber capacitor literally crammed underneath the transformer. Wow, if you ever had to change this diode back here, woo-wee. Hello, guys. You'd have to pull the transformer. Oh no, I would reach right in there, I'd cut that leg, and then I would put I'd solder that diode underneath. Good one, Maxonics. Good one. Oh, what was I doing? Oh, hey, I was checking to see if I had my proper gate resistance values, and I don't. And I never will. Let me grab my power supply. And let's see if this thing... I thought I already checked the power supply card. I could be wrong. Scope is up 5 volts. Division, we're at 10 microseconds. Probe. Let's do I have a short? Nope, no short. You'll know if you have a short, your power supply will cycle. Well, if you're using the right power supply. You should be using a current limited power supply, or current limiting, well, I used to use current limiting resistors, but I'd rather have the supply shut off. That's what I check for when I first turn it on. I check for a blue light down there on my power supply. Blue light's on, that means I don't have any shorts here. And then I fill for the drivers, make sure I don't have any shorts across drivers. Drivers have 12 volts on them and ground. So it should be okay to bump the power supply. Should be. Yes. We're not going to build any rail voltage because we're not going to have any switching. And we're not going to have any auxiliary power because we have no switching. So what we're going to do is we're just going to make sure that we have switching. Oh, darn it. Did I give that away? I probably did, guys, didn't I? Let me show you what we got going on. We're going to search for my scope here. Rigol, there you are. Select, and then we're going to go ahead and fire that up, and we're going to bring it up on OBS. Are we still alive? Oh, we are still good. We are at 27 minutes. We're doing good. All right, guys. Scope's on. Let's go ahead and fire this up. There, relay. Relay clicks in. I did not check this amp before. I'm sorry. I apologize. Because this is switching at... $38 kilohertz. Whoa. Isn't that a little fast? That does seem a little high. 38 kilohertz. But the thing is, though, is we have drive. Of course we have drive. I'm going to check drive on every gate pad. Looking good, looking good, looking good. I can't believe we're driving it at 38 kilohertz, though. 5.3 volts is our gate signal. It's about perfect. I mean, you couldn't be any more spot on than that. Let me look at the drive card real quick and see if anyone has done any work on the timing of this. My helping eyeball, my gray hair. Sorry, guys. Oh, well, looky here. Well, that's not very nice. There has been some work done, it looks like, on the resistor and capacitor. Uh-oh. Oh no, is it glitching out? It is. How long has it been doing that? I should look at my screen more often. Hmm. I'll catch that. Hopefully I'll catch it on editing. It's garbage. Sorry, guys. Okay, where was I? Oh, the drive. So 37 kilohertz is probably the reason why the power supply is dead. I don't know if I'd switch the 064s at 38 kilohertz. I may replace that drive card. I have, oh, you know what? Oh, I don't have that particular drive card. No, 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 no. Maxonics, come on. That camera. Sorry, guys. Well, darn it. I do have one of these power supply cards, but it's, or maybe I don't. Oh my gosh. Well, I'm going to dig into that. So, we do have gate. We do have drive. All right. 38 kilohertz. 40% duty cycle. It's really odd. I think that particular drive card is, it could be right, it could be wrong. I'm not so sure about that, but that is a little higher than average. So let's go ahead and turn off the power. I'm going to discharge my power supply. And the 12-volt capacitors. Why? Because you're going to have 12 volts when you go to put your power supply transistors in. And there we go. If you short that 12 volts to the gate, depending on the amplifier and how it's designed, that 12 volts that you short to the gate could damage the gate drive. Boo, my camera. Boo. Let me see if I can assist this thing. It probably is going to say, it's probably going to tell me no. That's not too bad. We're a little closer to, I guess. All right. That'll be on my equipment list. Wait, hasn't been on my equipment list for like a year now. Ah, you see that? Yeah, equipment. Let's see here. Let's see here. Let's see here. Let's see if I can. Let's see if I can. There. 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 Is it? It says nope. Still no good. Maybe? Am I getting somewhere now? Maybe. I know, guys. See, right? The things I got to battle with here. All right. It's okay. Moving on. So these lay down flat. It looks like they are using just the very end of the transistor. Oh yeah. Darn you, camera. Oh yeah, I edit that out. I'm not live. It's just recording because this camera's being retarded. I gotta buy me a new one. Again. lead free. You know, guys, you know how much I love lead free solder. Sheesh. Give me a break. Come on, guys. Oh, there we go. It's probably gonna be out of my thumb. I'm tired of burning myself. If there's one thing that you're gonna have to get used to if you do amplifier repair, that is burning yourself. And it's just like the Brazilian boards. I just do slight bends, slight curves. What do they call that? Long radius. There we go. Long radius bends on the transistors will help avoid failure from vibration damage. Help, I should say. Won't prevent. It'll help. I cannot. I can't stop vibration damage. Only you guys can. So that's just something I'd keep in mind. When building your systems or running your systems, that a lot of failures are from vibration. Or in this case, if I had to guess right, probably somebody has changed the capacitor value of the power supply drive card, which this uses the 494, so you right off the bat kind of know that this is a design that's controlled by a resistor and a capacitor. I do believe is what sets your frequency. So I do believe the frequency has probably been changed on this. Hopefully I'm not too far out. Let me see what these guys did. Nah, it doesn't look like it. Oh, and the heatsink is at a slight angle. Oh, you see that? Oh, my favorite camera of all times. I thought that was kind of interesting. So power supply transistors are installed and soldered in place. Now, this is where I'm going to hook up the power again, but I am going to use the thermal imager. Hold on, I have a short. Which one? Oh man, hold on. What's going on here? Why? That usually is a short on the gate. Oh, hold on, I have a short over here. Oh, I do. I have a drain. I have a drain source short. Why is that? Why is that? Hold on, I'll find it. I'll find you. Oh, I found you. Much better. Just goes to show, guys, that when you're soldering things, the smallest I mean, the smallest little solder ball can short something out to a point where it won't work. Now, if I would have hooked this up directly to a car battery, it would have blown that short out for me, but it probably would have taken out the power supply again because it was a drain source short, which is good because it means it's not a gate source short, so that means my gate should be okay. Blue light. There we go, that's better. Blue light, of course, means that I have good power. Man, this thing is gonna drive me absolutely crazy. Alright, let's see if we can make that. Alright, where was I? Scope. Oh, imager. Sometimes you got to be careful with these Maxonics boards because the rail capacitors could have a short. I've had that happen quite a few times. This camera is still doing it. I'm just going to double check and make sure I don't have anything that's going to heat up drastically. All right. Just want to make sure. Oh, yeah. I'm seeing some heat over there, but it could be just from when I just soldered it. So let me just double check, make sure that I don't have rail capacitors that heat up, power supplies that heat up. Nice, we're good. Voltage regulator is heating up. That's good. That's a good sign. That's what we're looking for. The other voltage regulator, wherever it's at, there's the resistor. Good, 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 good. All right, we're looking good. Let's see what our rail voltage is for this fine amplifier. 84 volts is the voltage of this particular board. Not too bad, not too bad. That's yeah, 38 kilohertz. Nice. Okay, well, that's the power supply. So we have power. We have our plus minus rail voltage. We have our auxiliary voltages. Sure enough. This is the IRS 21844 based drive IC. Which the heatsink is extremely cold. Almost concerning. So if this was a functioning output, you would have drive only on the low side, not on the high side. I'm assuming this is low side. Usually the low side's always towards me. And you can always tell because it's going to go to negative rail. So we want to bring out our voltage on the scope because it's going to swing to negative rail. And this will tell us if we have drive. Oh, well, look at this. All right, there is your negative rail drive. So when I say, if I'm helping you and I say referenced to negative rail, what I mean is you're going to find that signal referenced to whatever your negative rail is. That's why I had mentioned what our negative rail voltage is, so you can see that we are at the right voltage on our drive. So our drive is at 80 volts. So we're that's after all the filtering and everything. So we're going to rise up. Let's do the math real quick if we can. So what I did is I captured the screen and I'm adjusting my scope to help demonstrate what I'm trying to explain. So you can capture the image and then blow it up to measure whatever you're looking for or look for anything odd in the drive just by knowing how to run your scope. So our negative rail is riding at a negative 86 volts. Our drive is going up to 72. It's easy. So if you do the math, if you subtract the top of your drive signal, let me see if I can do this. If you subtract the top from the bottom, you're going to get your amplitude of your negative rail drive, which comes out to roughly about 14 to 15 volts. And that is exactly what I'm looking for. I'm looking for that negative rail drive. So more often than not, if you have negative rail, you can put your output transistors in. Let me put my scope back together here real quick. You can put your transistors in and fire it back up. If there's a problem with the chip itself, it's more than likely going to go into protection. And see the gate here, there's nothing there that I'm concerned about. So I'm going to go ahead and load up the output transistors. Once, of course, the rail has been discharged, which we're going to give it a helping hand. This will take just a second. Yeah, what I have hooked up right here is a resistor that's discharging the rail for me, because again, I am not going to install transistors with rail voltage present. All right, there's the new output transistors. Somewhat straight, of course. And let's go ahead and throw down some solder on these real quick here to keep them in place for when I flip it over, they don't go anywhere. Just like that. And we're going to go ahead and flip it on over. Figured I'd turn my power supply off just in case. You never know if something got 12 volts and started while I was working on it. I don't want that 80 volts in me personally. And again, you're going to want to make sure that these traces are well soldered. You may think, well, they're never going to pull enough current to, you know, blow these traces with this board. Well, you just never know. I mean, the 250N is still a pretty decently sized transistor. I mean, sure, there are bigger ones out there, but it's still pretty decently sized. So I wouldn't underestimate this. The IRP 250 has been used for a long time. The 250s, 260s, 264s. I carry them all. Because I do a lot of work on the older amplifiers. There are some older boards that use like the 264s. I'm just giving a little helping hand to this trace here. Yeah, camera, go ahead, keep on going. Maybe if I turned autofocus off, it would quit doing that. It's actually a grounding issue, right? Go figure. All right. So this thing now, if there's no drive issues, will fire right up. Do we believe it will? I have no idea. Have I done enough of these to think that it might? Yeah, it's got a 50-50 chance right now. All potentiometers fully counterclockwise. Thank you very much. Make sure that you are in master mode. I get this quite a bit, guys. They'll get amplifiers come in, they say there's no sound. Well, I'll flip the switch, and voila, it works again. If you are in slave mode, you will have no sound. Again, depending on design of amplifier. So, now, it's either going to work or it's not going to work. This, I'm going to be looking for the drive of the high side drain. That is what's going to show me. These are self-oscillating cards, so you don't need an input signal to start these. I just realized this is a Hifonics board that you can strap. Why would you strap this? Okay. I just realized that. There's times where I do have to probably just take a break. BW100 contact cleaner. Yes, 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 yes. Thank you, Steve. Thank you, Steve from Tronics Fix. I do support other channels the best I can, as much as possible. So not only is this a great cleaner, but man, does it cool down components fast, and it evaporates fast. So I use it not only to clean my potentiometers and switches, but I also use it to cool down my transistors, which now it's too cold. So now my colors have shifted all the way around. Nice. All right, so let's go ahead and give it some power. Blue light, blue light. You guys are not going to be able to see the LEDs, but, oh, change the voltage. Let's see what that IC does. It's either going to blow up. It says, nope, sorry, not going to do it. It says, oh yeah, we are. What am I was on the drain of the high side. Well, I needed to be on the source. And there is your square wave. Of the output. Well, that was fun. Not really. It was actually kind of boring, but no. Every amplifier rebuild is fun. It's just I have done so many of these that it's like it's hard to explain, but when you start fixing this many amplifiers in a week, you see the same thing. I'm just going to verify the frequencies and everything and make sure that's all good before this thing pukes out on me from heat. 114 kilohertz, yeah, I'm no issue with that. This is a little high. The power supply is a little high, but it doesn't heat up. I think probably by design, maybe that's why earlier boards were failing so much. I'm not sure, but this is 38 kilohertz as a note. Let's see here. Otherwise, that's this amplifier back up and running. I just got to get a little bit of a barrier put in between the drivers and the transformer. I'm actually going to use it as kind of a heat barrier also, kind of like what they did from the factory. I don't know where that little plastic piece went, but I use cardboard. Flameproof cardboard that you can find out of other amplifiers. Well, that's this board, guys. Oh wait, let's see. Let's make sure the preamp works. So I'm going to put in a signal of 50 hertz input, of course. Input. I know I'm using both white ones. I have a broken ground in one of my red ones, so but it's a mono amp, doesn't matter. Let's see here. So 50 hertz, we'll turn the signal generator on. 2-volt input. Potentiometers are all the way down. This is not going to be at 50 volts. We're going to go ahead and determine which one is from the relay. Here we go. Gotcha. All right, guys. Do we have a 50 hertz signal? Why, yes we do. There it is, guys. There it is. just the way it should be. Perfection. No noise whatsoever. That's it. What I do is I put it back together, get it on the load bench behind me, test it all out, heat the thing up, see what shifts around, see what fails, or if anything does fail, it fails pretty quick. If nothing fails, then it goes back to the customer. Well, thanks guys for watching. This is another amplifier rebuild of a Hifonics amplifier. And again, please guys, keep your fingers safe. The rail voltages here can get a little high, can be dangerous voltages. This is for educational purposes to help explain and demonstrate the functions of an amplifier. If you are not familiar with electricity, please do not open up these amplifiers. As always, guys, stay safe out there. Thanks for watching. Catch you on the next one.